Hi, good morning everyone. Today we are going to learn about the concept of duality and problems related on duality. Today let's try to understand what is this duality. Okay, so coming to here, duality is nothing but, for example, you consider a network having an a DC network consisting of an resistance, consisting of an inductor, consisting of an capacitor. I'm applying some source voltage of V, and the voltage across the inductor is VR, the voltage across the resistor is VL, and the voltage across the capacitor is VL, and the voltage across the capacitor is VC. So the dual for this network, the voltage source will be converted into an current source, and the resistor which is there will be connected in parallel, and the inductor what is there will be connected in parallel, and the capacitor what is there in series will be connected here in parallel. This is how we are going to have the dual network. So here when you apply, this is the total current I. The current across the resistor I am going to write down it as RR. The current across the inductor I am writing it as IL. The current across the capacitor I am going to write down it as IC. So when you apply the KVL, so current is already entering, current is leaving is negative polarity, already polarities are marked. What is the voltage at this point? V. When you apply the KVL, so the total voltage is V, and the current is leaving is minus VR, and current is leaving, the leaving polarity is minus VL, and the current is leaving, the leaving polarity is minus VC is equal to 0. But when you come to here, I have to apply, here we are going to apply, we applied Kirchhoff's voltage law. So now here we are going to apply Kirchhoff's current law. So total entering current is I. So what is the entering current at this node? Apply KCL at this node. And how many entering branches are there? I is entering, and they are leaving it as a IR plus IL plus IC. So the dual of this network is this network. So here you have resistor in series, here you have the resistor in parallel, here you have the inductor in series, here you have the inductor in parallel, here you have inductor capacitor in series, here also you have the capacitor in parallel. That's how we can replace one network. They have same mathematical form. These two equations are of same mathematical form, but they are not equivalent. Each this network, this equation are not equivalent, but mathematically these are same. So that's why a dual network have same mathematical form, but the dual networks are not equivalent to each other. This is what we have to understand. So this is how we are going to analyze. Let us try to draw the dual concept. So already we know that the voltage across the inductor V equal to L di by dt, and the voltage across the capacitor equal to I C dV by dt. So here this is nothing but voltage across the inductor. If you want the voltage across the inductor is equal to 1 by L integral of V dt. Here if you want the voltage across the, sorry, here you want the I equal to C dV by dt. Here if you want the voltage across the capacitor, V equal to, this will come down 1 by C integral of I dt. So that's how we have the voltage across the inductor and current across the capacitor. That's we have current across the inductor and voltage across the capacitor. So these are the two formats we can express. So here in the dual network of voltage is nothing but current across the capacitor. Here the current across the inductor is nothing but voltage across the capacitor. Let's try to do some analysis of dual of each other. So let's try to do it. So first at right side we are going to have element. So we'll take each element and try to draw the dual of this element, the dual element. Let's try to do one by one. Let's take the first element is resistor. So here you have the resistor, and here you are going to have 1 by R, where this 1 by R is nothing but G, the ultimate units are conductance. So second one the dual of resistor is nothing but conductance. The dual of conductance is nothing but resistance. And here you have capacitor in farad. So here you are going to have the equivalent is nothing but inductor in henries. So third one, you are going to have a series branch. So here you are going to have a series branch, and here you are going to have a parallel branch. So the dual of series is nothing but parallel. So fourth one, we are going to have, here you are going to have an voltage source of V magnitude, and here you are going to have a current source I, where current I is equal to V minus 0 by R. So the dual of voltage source is nothing but an current source. So coming to the next one, so let us take this. We have a switch like this, and switch is closed at t equal to 0. So here you are going to have, you have a switch, and switch is opened at t equal to 0. So dual of this switch closing is equal to the switch opening, the next dual. So coming to the next dual network, so here you have a mesh. So this is some like one voltage source and resistance here. So here you have an mesh, a current of I. This is nothing but V R1 R2. So where I is called the loop current. Here you are going to perform mesh analysis. Here the same you are going to get the nodal analysis. The voltage here it is known as V. Automatically this will be a new node where this is called nodal. So here if you perform by mesh analysis, so here you have to find out the nodal analysis yet node V1. So here whatever you have the mesh here, here you are going to have the node. So the dual of mesh is nothing but node. The dual of, here you apply Kirchhoff's voltage law in mesh analysis. In nodal analysis is going to find out KCL. The dual of KCL is nothing, the dual of KVL is nothing but KVL. The dual of KCL is nothing but KVL. Both are dual in nature. So that is nothing but the seventh one. So eighth one is nothing but you have open circuit as one element. Automatically this will be acting like an short circuit. So what is this open circuit and short circuit? Here it is open circuit. How much amount of the current is flowing? Zero current is flowing. If the current is zero, automatic resistance is infinite, and automatically voltage is maximum in the concept of open circuit. Open circuit will have current is 0, and you can write down V equal to I into R. So V by R is equal to I. So I want the current as 0. When current I will be 0, when it offers infinity resistance. So current will be 0 only when infinity resistance is infinity, and if it is open circuited, one terminal will be of high potential and another terminal will be of low potential. So here it is maximum voltage, here it is lesser voltage. So here open circuit, the dual network is short circuit. Whenever you are going to short circuit, the voltage becomes 0 and resistance also will become 0 and current will be maximum, where this current, maximum current, is also called as a short circuit current. So I can say that the dual of an open circuit is nothing but an short circuit. The dual of a short circuit is nothing but an open circuit. Let's try to see the next comparison. For example, here you have Thevenin's theorem. The dual of the Thevenin's theorem you will be having as Norton's theorem. The dual of Thevenin's theorem here. So if you draw this Thevenin's theorem, you have an voltage source and an series resistor. You are going to have, this is nothing but open circuit voltage. This is called Thevenin resistance. This is called load resistance. But when you come here, you are going to have the current, where this current is called short circuit current, where the resistor is connected in parallel, where this is called as a northern resistance, and here you are going to have the load resistance RL. So you can see here the dual of this network is nothing but this network. Here voltage is replaced, voltage source is replaced with current source, and R Thevenin and RL are connected in series. Here R Thevenin and RL are connected in parallel. So I can say this is in a series connection. The dual of series connection is nothing but parallel connection. The dual of parallel connection is nothing but series connection. Here you have the voltage source and here you have the current source. So that's I can say that a Thevenin's theorem dual network is nothing but an Norton's theorem. So coming to the next one. So here if you have a star connected system, here you are going to have a delta connected system. So we can, the equivalent of star is nothing but delta, the dual of an delta is nothing but the star. So I think you know the relations each other. So here in the case of a star, phase voltage is equal to line voltage. Here phase voltage is equal to line voltage by root 3, and I phase is equal to IL, but here it is reverse. So phase current is equal to IL by root 3, and phase voltage is equal to line voltage. So this is like for example how it is given is phase voltage is 230 and line voltage is 440. So when you divide 440 by root 3, then you will get the lower magnitude. That phase voltage is nothing but the voltage what you get your house, and line voltage is nothing but the voltage. So I can say that in a star connection system can be converted into delta connected system like this fashion. The dual of delta is also an star. So this is one more. Okay, so like this we can derive everything. Okay, next one already I discussed. So the voltage across the inductor V equal to L d I, voltage, I mean current across the inductor divided by dt. Here we'll discuss about here voltage is here automatically current across the capacitor, current I equal to C by dt. So here you get inductor and automatically you are going to get the capacitor here. Let us try to solve the problems. Try to recall the things. So resistor dual is conductance, the dual of capacitor is inductance in Henry, the dual of series network is parallel resistor, the dual of voltage source is current source, the dual of switch is closed is the switch is open. Here we apply mesh analysis, the dual is nodal analysis. Here in mesh analysis we apply KCL, KVL, here we are going to apply KVL. So here we are going to perform open circuit. In open circuit current is 0, resistance is infinity, voltage is maximum. The dual of open circuit is nothing but the short circuit. In short circuit resistance is 0, voltage is 0 and current is maximum. And here the dual of Thevenin's theorem is equal to Norton's theorem. Here you have a voltage source, here you have a current source. R Thevenin, RL are connected in series. Here R Thevenin, RL are connected in parallel. So the equivalent of a star is nothing but delta. Here you have phase voltage is equal to line voltage by 3. Here you have phase current is equal to line current by root 3. So here you have voltage across the inductor is L dI by dt. Here you have current across the capacitor is C dy by dt. So this is how to draw it. Let's try to solve one problem on dual networks. So coming to the procedure is very simple. There's no need to worry. So of finding procedure of finding dual network using graphical method. So this like graph we are going to draw it and we are going to find the dual of an given network using graphical method. Let's try to see some steps. Let's try to go into the problem. So first step is first identify the individual loops. Identify how many loop currents are there, I1 and I2. So after identify the loop currents, replace the loop currents with an nodes as node V1 as node 1. For loop I1 replace node V1. So for loop I2 replace with an one more node V2. So third one is so with respect to this node 1 and node 2, you try to draw an reference node. Here this is called 0 volts and this is called as a reference node, or this is also called zero potential. Zero potential. So fourth point is so identify the elements which are touching loop 1. Okay, so when you identify the elements which are touching loop 1, so what I have to do is already you have one first node is identified. So for example you have a network like this and you are going to close. So here is nothing but loop I1. So when you have the loop I1, what I have to do is identify the node as 1 and identify the reference node as 0. So loop I1 is touching voltage source and R1. So now join a point, so from 1 to 0 with the help of an voltage source. Join R1 with the help of 1 to 0, and here the current is flowing like this. So you see here, current I1 is concerned with this voltage source and R1. Okay. So this is how we are going to draw the elements. So next, for example, fifth step is, if you have an element common to first node and second node. For example, you have an inductor common. You try to draw the neural network like this, 1 and 2, and between 1 and 2 you try to indicate with an capacitance. That's all. So this, the dual of this will be like this. So this is how to identify. The next point you have to remember is, so when you have an voltage source, okay, so how to indicate the graph direction is, so this is the first node and this is nothing the second node. So here you have an voltage source. You have to indicate the current source in such a way that it flows towards the node. So you can see here the current is flowing like this. The current direction and voltage are in the same direction. That's why you have to show the voltage source which is also entering and which enters the node. Enter the node. So remaining other than sources, which is nothing but resistance, inductance, they will be leaving the node. Okay. So whenever this is nothing but voltage drops, you have to indicate that they leave the node. If you have an voltage sources which are in the same direction of current, then you have to write down as they enter the node. Okay, you have to draw them as they are entering the node. The current is entering the node when you have voltage sources. If there is no voltage source, so this resistor and this capacitor and this inductor act as a drop. All the voltage drops, you have to draw that they are leaving the node. So this is the 4 points you have to remember while you are performing the graphical analysis. First, identify the individual loops of the network. Replace the individual loops with an node 1 and node 2. And third one, mark an reference node, and this reference node is drawn outside the network. So fourth one is, so already you identified loop 1. So the currents which are touching loop 1, so try to draw the node inside 1 and try to touch all the elements which are touching the same branch. So current I1 is touching the voltage source and current I1 is touching the resistor. So join the points 1 to 0 by using voltage source, join 1 to 0 by using resistor. Now let us try to solve one problem. We can have a more clarity. So the given problem is problem number 1 or example 1. Draw the dual network. Draw the dual network or the network shown below. So the dual network is a voltage source and a resistor R and an inductor, and you have an capacitor and you have a resistor R2. So this is R2 ohms, this is C farads, this is of L inductance, this is of R1 ohms, this is nothing but voltage. So now how to draw the dual of this is, first identify the loop currents. This is nothing but the loop current I1, this is nothing but the loop current I2. So now draw the dual for this. So how to draw is, so first draw the given network as it is, and here you have an capacitor and here you have an resistor. This is R2, this is C, this is L, this is R1, this is V. So this loop is replaced with an node, this is 1, and this loop 2 is replaced with an second node as per the second step, and replace an reference node or ground potential as reference. Now try to You see here, this I1 loop is touching voltage source and R1. Okay, so now try to draw the elements. Current I1 is touching the voltage source. This is one direction, and loop I1 is touching the next element is resistor. So draw an dotted line from 1 to 0, and actually they travel in this direction. So now, so similarly, current I2 is touching the branches capacitor, and current I2 is touching the branch R2. So now from the second node is touching the 0th node via R2, and second node is touching the capacitor. Second node is touching the capacitor through the dotted line as it is indicated. Now, so there is a link between first node to second node. Draw it like this. Now let's try to redraw the network. So we have the elements here. We go first node, second node, and zero node or reference node. So now 1 to 0, what is the element? We have voltage source. So replace 1 to 0 with an current source and replace the value as I. So 1 to 0 you have an R1. So replace that R1 with conductance, which is nothing but G1 mho. And next 1 to 0, two elements completed. Next 2 to 0 you have R2. So 2 to 0 you are going to have one more element, and this will be G2. And next 2 to 0 you have an capacitor. Replace that capacitor and try to write down an inductor, and this will be L farads, and here this is in sorry, this is in capacitance in farads, and the same capacitance is replaced with inductance, and here you are going to have Henry. And now you see here, this voltage source and this resistive branch are in series connection. This current source and this conductance are in, so these two are in parallel. So these two are in which connection? Series. So the dual is drawn. So now between 1 and 2 you have an inductor. Now between 1 and 2. So this is also first node only. This is also second node only. This is of zero potential, zero potential, zero potential, zero potential. Between 1 and 2 you have an inductor. Replace that inductor with an capacitor like this. And here you are going to get farad, or because already here you have an Henry. So this is the dual network. Basically, mathematically, they may be same, but they are not equivalent. They are not equivalent, but mathematically they are same. This is how to draw an dual network. I repeat the problem again. So you have an voltage source R1. So current I1 is flowing across V and R1. Current I2 is flowing across capacitor and R2. So this inductor is common to first node and second node. So replace loops I1 with a node V1. Replace the loop I2 with an second node and draw an outer node at the outside. So current I1 is touching the voltage source and R1. So similarly, so node 1 is also touches voltage source, and node 1 also will touches the resistor R1. Separate to draw the with a dotted line. And similarly, current I2 is touching inductor and resistor. Similarly, from 2 join a dotted line which joins a 0 node. From 2 join the capacitor with a dotted line. And here you have voltage. So the equivalent of voltage is current connected between 1 and 0. So between 1 and 0, what is connected? R1 is connected. Here you have G1. So here you have between 2 and 0 you have R2 ohms. Here you have G2 conductance. Between 2 to 0 you have capacitor. Here you have inductance. Between 1 and 2 you have inductor. So here you are going to get the capacitor. So that is how to draw the dual network. Let's try to solve one more problem which will make the things much better. So we have a network like this. Second problem, we have an voltage source, we have an resistor, you have an inductor, and we have an capacitor. So this is R, this is L Henry, C Farad, and the current of I1 is flowing. So we need to draw. So the question is asked is draw the dual network for the given circuit. So you see here how to draw is so redraw the same network with R, L as well as C. This is V, R, L, C, and replace this current I1 with an node. How many currents are there? Only one current, therefore only one node, and try to mark a reference node at the bottom. So current I1 is touching voltage source V1, resistor R, inductor L, capacitor Farad. Similarly, node 1 also will touches all the, so draw the dotted line which touches 1 to 0. Next one, draw 1 to 0 touching R1. So draw 1 to 0 touching inductor. Similarly, draw 1 to 0 touching the capacitor. You can see here all the elements are traveling from 1 to 0 with respect to their elements. And I already told the current travels in this direction from reference to 1, reference to 1. So the dual for this is I'm going to mark node 1 and I'm going to mark 0. So between 1 and 2 what is there? Voltage source is there. Here you are going to get a current source, current I. So here you are going to have an inductor between 1 and 0. So now between 1 and 0 also you are going to have G. The units are mohs. Between 1 and 0 you have an inductance. Now between 1 and 0 you are going to have an capacitance, C farad. So between 1 and 0 you have an capacitor. Now the capacitor will act like an inductor, and this is nothing but L henries. So the dual of this given network is this network. This is electrically not equivalent, but they are mathematically same. That's how to write. And already I told this is node 1. If it is a voltage source, the current will enter the node. If it's not a voltage source, if it is a voltage source, it will current source, it will enter. The remaining elements will leave the current like this. So you can see here all the elements are connected in series connection. Here the dual for this, all the elements are connected in parallel. So here you have a voltage source, here you are going to have a current source. Here you have a resistor, the reverse is conductance. Here you have an inductor, the reverse is, the dual is capacitor. Here you have a capacitor, the dual of capacitor is inductance. It's how we are drawing a dual network for a given problem. This is about the second problem. Let's try to go to the third problem. Let's try to take with respect to some numericals. So voltage source, and you have an resistance, and you have an inductance, and you have resistance, and you have an capacitance. So the values given to here is, so this is of 10 volts, this is of 2 ohm, this is of 5 henry, this is of 1 ohm, this is of 2 farad. So the currents are marked like this. This is loop I1, this is loop I2. So now redraw the network. So same network, you try to redraw it. Ten volts, 2 ohm, 5 henry, 1 ohm, 2 farad. So replace these loops with an nodes. Replace the loops with an node and mark this node as 1 and this loop as node 2, and try to mark a reference node. Now I1 is touching the voltage and resistor. So now you see here. So try to draw the dotted line. Node 1 also will touch voltage source via this dotted line. Node 1 also will touch the branch 2 ohm like this, and the current is traveling like this. Next, so node 2, I mean the current is touching 1 ohm resistor and 2 farad. So how to draw this second node is, so draw a dotted line touching the capacitor with respect to 0, and with respect to 2 resistance is also touching. So here the current is traveling between 1 and 2. We are also having a touching point. So now redraw the network. So this is node 1, this is node 2, this is a zeroth node or reference node. Between 1 and 2, what are the elements connected? You have a current source. Redraw it. Just what is the magnitude given here? 10 volts. Just write down the as it is magnitude, and what are the voltage given here? Voltage. Just write down it as a current. So here you have a 2 ohm resistor between connected between 1 and 0. So between 1 and 0 you are going to have an conductance. What is the value of the resistor given? 2. Write down the 2. And what are the units here? Ohms. Here you are going to get mho. Now between 2 and 0, what are the elements connected? One is a capacitor is connected. So between 1 and 0, you are going to have an inductance. And what is the value of this inductance? So here it is how many farads? 2 farad. Write down the 2 farad as it is. And here it is farads. Here we are going to get in Henry. Between 2 and 0, you have one more resistance. The resistance can be replaced with an conductance. This is nothing but, so what is the value of resistor value given? 1. Write down the 1 as it is. Here the units given is in ohms. Here you are going to get is mho. So between 1 and 2, you are having an inductor. So inductor dual network is nothing but an capacitor. And what is the value of inductance given? 5. And here it will be 5 farad. So this is how we are going to construct the dual network. So this is how we are going to construct a dual network for an given problem. So this is how to understand the concept. Let us try to solve one more problem which makes the things more clear. So last problem will solve fourth problem. So here you have one switch, and here you have one battery, and here you have one resistor and inductor, and this is closed with an capacitor. The values are C, R1, L1. This is voltage source. This is switch is closed at t equal to 0. Switch is closing, and here you have an inductance, and after this inductance you have an resistance. Inductance is L3, resistance is R3. Between these two nodes you are going to have a current source which is connected like this, and the value of this is I0. And between this you have one more element. So this is nothing but some R2. Now for this given network, draw the dual network. You can see here this is carries a loop current of I1, this carries a loop current of I2, this carries a loop current of I3. Now we want to draw the dual for this network. So how to draw the dual for this network? So it's very simple. So try to redraw the network as it is. Okay, so try to redraw the network as it is, and replace these currents with an node. Just redraw it. So replace this with an loop current with 1, and here, okay, let's try to draw for your more convenience. I want to draw it more clearly. So here we are going to have a loop current of I1, a loop current of I2, and a loop current of I3. So when you are going to redraw it, so here you are going to have the network like this: resistance, inductance, and they are joined with capacitance, and you have one inductance and you have one resistor, and between these two elements you have an current source which is drawn like this. And between these two, we are going to have the resistance value of R2, Vg, S1, R1, L1, C, R3, L3, and I0. So how to draw the dual? I think you know the things very better. So instead of loop I1, we try to draw the node 1. Instead of loop current I2, draw node 2, and instead of this loop, we try to draw node 3 and try to mark a reference node at reference. So now you see here, loop I1 touches V1 switch and R1 and R1. So these three elements it is touching. So now with respect to 1 to 0 also, we want to draw node 1 is touching voltage source. Node 1 to 0, you have one more connection. Node 1 to 0 you have through R1 one branch. And next node 2 to 0 you have one more branch, and node 2 to 0 via L3 you have one more branch. All will travel from 0 to the reference nodes. Next one, node 2 to 0 completed. This element is to common to this one is common, and this is common to this. And node 3 to 0 current source is traveling. Between 1 and 2 you have an inductance. Between 1 and 2 you have an capacitance. Between 2 and 3 you have an inductance. Now we are going to draw the dual for this. So mark the nodes as it is 1, 2 and 3, and the reference is 0 reference. Now 1 and 2 you have an voltage source. So replace that voltage source and replace with an current source, and the value given here is Vg, sorry Ig. So here you are going to get Ig. So here the switch is opened. Sorry, here the direction given is the switch is closed at t equal to 0. So now how the switch will be there? Switch will be closed. Switch is closed at t equal to 0. Here it is open, here it is closed. Between 1 to 0 you have R1. So between 1 to 0 you are going to have G1. The units are moles. So now 1 completed. Coming to the 2. So between 2 to 0 you have R3. 2 to 0 you have R3, and we are going to have G3. Between 2 to 0 you have inductance, and you may have the capacitance. Okay, so the capacity here you are having G3, and here you have L3, and here you have C3. So now 3 to 0 you have an current source. Here we are going to have an voltage source, and this is nothing but V0. So now link each network. So this completely will act as an which node? One node, and this completely will act as an second node. This will act as an third node. Between 1 and 2 you have an capacitor. Between 1 and 2 you are going to have an inductor. The value is L. Between 2 and 3 you have an resistor. 2 and 3 you have an resistor. So what is the value of this resistor? R2 you are going to have G2. Between 1 and 3 you are going to have an inductor. So between 1 and 3 you are going to have an capacitor. And what is the value of this L1? So this will act as C1. This is how to construct all the branches of the given network. So this network can be represented in the dual form. You can see here. So here voltage source, switch, and rest are connected in series connection. Here current source, switch, and this are connected in parallel connection. So series and parallel are once again dual. So here you have the capacitance between 1 and 2. Between 1 and 2 you have an inductance. So this is how to understand the problems on dual. If you feel the content is useful, please give an like button and share to your friends, and subscribe to the channel if you are viewing the channel first time to get more updates. So hope the content you are able to understand. So directly seeing this video, you will not understand. First write down the given question as it is and try to solve of your own and see that you are getting the same solution what is mentioned. Hope the content is useful. So thanking for viewing you as a prompt.